Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning video brought to you by SQLworkshops.com. In this video, we will talk about SPU Pro, Getting Started, Part 1. First, we will look at how to download and set up SPU Pro. To download SPU Pro, you go to SQLdownload.com. Once you are in SQLdownload.com, you can click on Download. There you will see SPU Pro is available for various versions of SQL Server, starting from SQL Server 2005 SP4 until SQL 2014. You download the correct version of SPU Pro as per your installed SQL Server version. Once you downloaded the SPU Pro, you copy the script into a Management Studio query window and you can create the stored procedure. Let's create the stored procedure. Now we have downloaded and set up SPU Pro. If you are looking for documentation on SPU Pro, you can go to Documentation. There you will see documentation on SPU Pro. If you have questions, you can post to our forum. This is a Google forum where you can post your questions or look for answers. To display help for SPU Pro, you execute SPU Pro help. It gives you the help information. You can of course cut and paste this help information in another window to browse. Let's execute SPU Pro. When you execute SPU Pro, it shows you currently active sessions and blocking sessions. Right now there is no activity in this instance of SQL Server, so you get an empty result set. Let's start a blocking scenario. Let's go to SQL test. Here I have two workloads. The first workload does an update on tab 7, set C2 equal to 2 where C1 equal to 10. It begins a transaction. There you see it begins a transaction and it does the update, and before rollback it waits for 600,000 milliseconds. So it will wait for some time before it rolls back the transaction. So the row will be locked for 600 seconds. And we have a second workload. This workload selects from this table the same row that has been updated from workload 1. The setting for this workload is it will connect after 2 seconds. So this is the delay before connect. It will connect after 2 seconds. So the first connection will have time to connect and lock the row, and the second session will connect later and it will wait for the lock. So when we start this workload, there will be a lock wait scenario. Let's start this workload. Now we can execute SPU Pro. There you see there are two sessions, 57 and 66. If we look here, the session 66 is waiting for a lock and it is blocked by session 57. That's what you see here. The session 57 is blocking. So you get this nice output. If you want further information about this session and connection and request, you can browse through. It gives you the input buffer, the text and other information. If you want specific information like SQL, wait, block and logs, then you can give these parameters. The first set of parameters limit the sessions. The second set of parameter helps you choose which columns you want to see. So here we say I want to see SQL statement, wait, block and lock related information. I can execute this. It shows me the SQL statement. For example, 66 is the waiting session. We can click on the input buffer. It shows it's a select statement. And here we see 57 is the blocking statement. And when you click here, it says it is doing an update. And you can browse through. It shows you the lock resource, and it also gives you additional information about the lock resource, like the table name, the index, weight type, and other information. It also gives you locks info. Since we included locks in our output, it gives you the locks data. When you click on locks info, it shows you our waiting session is waiting for a key lock on this tab 7 and in this index. It asks lock granted for database, object, and page. So this is a conflicting lock. If we go to the previous session and look at lock info, it shows that this has lock granted on all the resource. It is not waiting, and it also has a key lock. In our case, this is the conflicting lock. Let's look more about columns. This is what we saw before. SQL wait block locks limited. Limited means it gives you a standard set of columns. If you want additional information, like one of my customers said, look, I have here the blocking session ID. I have here the blocking session ID, but I want the session ID next to it so I can, take a look. So in that case, what you can do is you can just add the column name session ID, r.blocking session ID as you like, and these columns will appear in the order you include in the column list. For example, you want additional information about wait. Who is a blocker? Is this session a blocker, or this session is, who is this session blocking? If you want additional details, you can look for wait detailed. When you execute with wait detailed, in addition to wait information, it will give you is blocker, is head blocker, is blocked, who all got blocked session IDs, and other information. What columns are available, you can always refer to the documentation. There you will see these are all the columns available for you to select: CPU, IO, memory, network, wait. These are column aliases. So if you say CPU, it will give you CPU related columns, IO related columns. If you say IO underscore detailed, it will give you IO related columns but detailed set of columns. So you have to choose what columns you want, and it also accepts a parameter all. So if you want to check out what are the parameters that are possible, you can look at the help information that we cut and paste in the beginning. Columns, you can say limited, output small set of columns. You can say all, output all columns. It's not recommended because it can fill up the disk in case you save this result to the database. And you have all other information in the help, what columns are possible. And you can also give these individual columns. You can say c.session ID, c.most recent session ID. All these columns that are available in these DMVs, you can select. Let's look at an example of monitoring CPU time. Here is the example for CPU, SQL CPU limited. When I execute, it will show you CPU usage by this request. First we have SQL, so it shows SQL related, and then it will show you CPU related, that is CPU time and total elapsed time and information like this. Let's start a CPU intensive workload. Here is a CPU intensive workload. I execute this query 1000 times. Let's start all. Now if you monitor, you will see CPU usage. You see this query is using 3.2 seconds of CPU. The query executed for 3.2 seconds. And if you click on the input buffer, it shows you the statement we just started in the tool. And let's look at an example for transaction related information. So here is a workload that is going to insert this large table. It just drops the table, creates the table, and inserts 200,000 rows, but this whole batch is executed for 1000 iterations. So let's start all. Now let's look at transaction related information. So when you execute, it will show you the transaction related information. You see in the input buffer, this is our create table statement. And when you go further, it shows you transaction log bytes used, transaction begin time, transaction log record count. Let's execute this statement again. Let's look how much transaction log bytes it has used. There you see, this is bytes. So you see how many bytes it has used in the transaction log and how many transaction log record it has returned in the database. With SPO Pro, you can also monitor memory and TempDB usage. For example, here I have a workload which does an order by. It executes it 1000 times. This order by allocates memory. At the same time, it spills to TempDB. So let's start this workload and we can check memory and TempDB usage. So when you execute, let's see which statement is our statement here. There you see use test and there is a declare an order by. Let's look at which statement is ours. So use test declare, you see this is our statement. So our session is 64. If you follow 64, it will show you how much memory the query was granted, on how much it is used maximum, and the TempDB usage as well. TempDB usage at the session level and TempDB usage at the task level. Let's refresh it to get the data. Again, it is session 64. There you will see the TempDB usage by the task is 400 megabytes. This should be memory and TempDB monitoring. Let's also do an example about physical I/O monitoring. Let's say we want to monitor physical I/O. Here is a query that I can execute. Drop clean buffers and select from tab 73 where C2 equal to 10. Of course, since we drop the buffers, the data will not be in the cache. It has to read from the disk. Let's start this workload. Let's save this. And here, instead of memory and TempDB, we can say I/O or I/O detailed. Once you have I/O detailed and when you execute this, you will see I/O related information. For example, this is our statement. You can click here to see drop clean buffers, the workload we just started, that is 65. And you will see I/O related information, the physical reads, that is the reads and the logical reads, and read pending I/O, read size, this is the read average read size, and it has quite a lot of information if you say I/O detailed. And finally, I want to show you what is this column called sr.input buffer. Normally, when a request is running, you can ask for the request input buffer. When the request is not running, you can ask for the session input buffer. Another example is this RC text. This is the text from the SQL handle. When a request is running, you have a SQL handle from the request which gives you the text. When the request is not running, you can get the text from the most recent SQL handle from the connection data structure. RC text means it is looking for request.text. If it is not available, then it will show you the connection.text. Let's look at this example. Let's look for r.text and c.text. For example, when we have a blocking session, we have no request. So the request.text is null. And we got only connection most recent SQL handle text. So when you simply say text, it will give you r.text. If r.text is null, then it will give you c.text. Let's look at the agenda. So that's about column selection. You can give aliases or you can give specific columns. You can also do order by. The columns that you give for order by should be in the output list. Let's look at an example. Let's go here. Here we are doing order by on total elapsed time descending and session ID. So when you execute, you will see the results ordered by total elapsed time. We can also have this total elapsed time part of our column selection so we can see it. We have here total elapsed time. We cannot say descending. We simply say r dot total elapsed time, and you see the elapsed time, it's ordered by descending. You can also say sr.inputBuffer or rc.text. If it is part of the output column, you can include that in the order by statement. The next topic is filtering sessions. Here, first parameter is the session filter. You can say session ID in, and you can give a set of session IDs. If there is a session ID in this list, there is a request or active sessions or any session, it will give you the output. You can also say active session, but session ID not in. Basically, you can say session ID in and not in. Both are supported. To look at help information on the sessions, you can go here. The SPU Pro help output. You can say active, which means active sessions. You can say null, which includes active and blocking sessions. And you can say wait means waiting sessions. Block means blocked and blocking sessions. Blockers and blocked sessions. You can say blocked or blocking, or you can say all sessions. These are all possible. You can also say save and no output. We will look at it a little bit later. Let's go back here and look at these filters. And further filters are available. That is, you can say is user process in. You can say 0 or 1. So these are all the in and not in parameters, and you have greater than, lesser than parameters. You can say CPU time, wait time, or you can say like parameters or not like, program name, and so on. Let's look at an example of greater than parameter. Here you can say SPU Pro CPU time greater than 10,000. This is in milliseconds. So if there is a request which is greater than 10,000 milliseconds, it should show you. Let's decrease the amount of time and execute. Greater than 100. Now it shows you the CPU time. If you want CPU time, you can include here r.cpu time, and then you will see also the values. You see r.cpu time. So let's say 1000, greater than 1000, and look for r.cpu time. There you see the rows that qualify with CPU time greater than 1000. And here you can also filter by host name. You can say host name not like SQL Workshops or like SQL Workshops. Then it gives you the sessions that qualify for this predicate. The next is saving to database. That we can go here, and if you want to save to a database, you simply include in the session list the save parameter. When you don't give a database name, it will save it in the current database, that is the master database. If you want to save it in a specific database, then you can say save and you can give the database name. Let's try that. Let's give the database name. Now it will save it in this database. Let me execute this query. It shows you the output. At the same time, it saves it in the database. Let's go to the database and look at the tables that are in this database SPU Pro DB. So I'm going to refresh, and there you see the connections, requests, sessions, these are all the tables where the output was persisted. Let's delete these tables. Right click, delete. Okay. Now let's execute the save statement again. Once you execute the save statements, of course it will create the corresponding tables to save. For example, if you look at the session data structure, right click, select script table as create to new query window. There you see the columns that are part of this SQL WS DM exec sessions. These are all the columns we requested with the columns parameter. In case we add additional columns, for example, I say here detailed. I want detailed set of columns. If I do a save now, and then we go to the database, refresh, and then we look at the columns part of the sessions, right click script create to query window, you will have more columns because this column list is dynamically added based on the column supplied with the save parameter. If you want to start this as a job, then you can use no output. Normally when you say save, it gives you the output at the same time it saves in the database. If you say no output, it will just save in the database and it will not give you the output, and this will be flexible to have as a SQL agent job. So we don't want output to going from the SQL agent job. Once the data has been saved, you can retrieve the data using SPO Pro. You can use SPO Pro and supply the parameter null and give the columns you want to select, and you say which database it has to retrieve the data from, because here we saved the data in SPO Pro DB before. So you give the database name. If you want to order by, you can give order by columns. The first set of parameter is the session filter, the column order by columns, and then the database name where to save. If you don't give this time from and to, it will save into the database when you have the save command. If you don't have the save command and if you give the time, it will read from the database. Let's adjust the times. Let's change it from 2013 to 2015. Let's change it from 2013 to 2015. So this will retrieve all the data in those tables that have a date range between 2013 10/16 to 2015 10/18. We can execute this query. These are the results. In case you want to look for particular date time, then you should give just one date time. Then you should not give this parameter, then it will retrieve data specific to this date. If you give a range, it will fetch the data for that range. There you see it. If you want the select statement itself and you want to execute the select statement, then you can say no output. If you say no output and execute this SPO Pro, you will get the select statement. With this select statement, you can cut and paste and execute it and you will see the output. This is actually joining the tables that was persisted by SPO Pro. This way you can have additional filters. You can follow one session equal to 61, for example. So when you execute, you will know the history of session 61. SPO Pro comes with different license types. Let's look at license types. To look at license types, you click on license. There is free community license, enterprise license, service provider, and solution provider license. You need service provider license if you are a consultant and you use this part of your consulting service for third party. If you are a solution provider, you are a software developer, you want to integrate this into your product, you need a solution provider license and you need to contact us. You can use free community license. There are some restrictions. You can read them in the EULA, and there is a brief note here. You cannot install SPU Pro for other users if you have free community license. You need enterprise license if you want to install SPU Pro on behalf of other users. And there are further restrictions. You need enterprise license in case you want to process the data collected by SPU Pro in an automated way to analyze or to generate alerts. Also, you need an enterprise license in case you want to engage a third-party consultant or use a third-party software, script, or computer program to analyze the collected data. The cost of the enterprise license is $45 per year, and you can click here to choose how many year license you want to buy, and this is a site license. Thanks for listening to this presentation. If you have any question related to SPU Pro, whether it's related to column selection, or you want to have new columns in this alias, or something is not working, just send me an email. And if you have suggestions to improve the product, of course, we welcome such suggestions. Thanks very much for your time again. Bye.